Hi everyone, it's Mrs. Griffin, the Unit 3, Lesson 10. We're going to be talking about how to do a reflection over a line on and off the coordinate plane. And you'll notice that this is basically just a flip. We're going to get a mirror image. Notation is going to be R sub L of your pre-image. Notice it's a lowercase r. And this L is going to be a line. And that can be in an equation or a label. It could be written a variety of ways. Okay, notice that I have a picture of a triangle being flipped over a line. This line we're going to call L. So notice that for point C, it's on the line L. Point C, when you reflect it over the line, you really can't. It stays where it is because it was on the line that you flipped. Point A, though, flipped over and actually did move to a new location, and we call that A prime. That's its image. And also notice that if you were to connect A to A prime, that this line segment has been bisected by the line of reflection and they are perpendicular. So the line of reflection is the perpendicular bisector if you were to connect an image and a pre-image together. Okay, another concept we're going to talk about is the concept of a symmetry. A symmetry is when you have an object that has a rigid motion performed onto it and it lands back onto itself. Okay, line symmetry means that you can flip an object over a line of reflection and you land it back on top of itself, so you can't tell which one's the image and the pre-image because they're on top of each other. You can't do that to this particular right triangle. But if this rectangle was flipped perfectly over this line that goes straight down the middle, it would land corner to corner back on top of itself. And the same thing would happen if you use the horizontal. All of these corners would land on the corners across from them. And you wouldn't be able to tell which one is the pre-image and which one is the image because it would overlap perfectly. So there are two lines of reflection for a rectangle. Okay, if you look at this hexagon, assuming it's regular, all of its sides and angles are congruent, then you can do a line of reflection straight through here, and it's the perpendicular bisector of the side, or here, perpendicular bisector, or here, perpendicular bisector. Or you could also bisect each angle, and you would have a perfect line here, perfect line here, perfect line here. And so the easiest way to think about it is to think about how you could possibly fold the shape in half. And so there are 6 on this hexagon. There are none on this parallelogram. A lot of people think that the diagonal would work, but if you notice, if I draw that diagonal in there, if I were to try and fold this corner across that line, it wouldn't land perfectly on the other corner like this. It would land next to it. This doesn't work. Right? And then finally, again, if this is a regular pentagon, I could bisect the angle, which is also the perpendicular bisector of the side, and this one, and this one, and this one, and this one. And so they perfectly cut each shape in half. They fold them perfectly, and so there are 5 here. Now, to do a construction, we need our compass. And so what we're going to do is we're going to do a perpendicular bisector between 2 points that correspond, for example, D and D prime. So we're going to move our compass and we're going to open more than halfway between D and D prime, and we're going to swing that arc. Okay. Then we'll flip it around and move it over to D prime and do another arc that's the same size. And when you connect those, you'll get your line of reflection. And you could also do that within one of our shapes to get a symmetry line. Okay, same thing on the next shape. We want to go between 2 points that correspond, like F and F prime. And we're going to open our compass so that it's more than halfway between F and F prime. And we're going to swing an arc. And then we're going to flip it around and go to the other point and swing another arc. And then when we connect, those make the line of reflection. Okay, for number 3, we're going to practice using our notation. So this says we're going to take point B and we're going to reflect it over line L. So point B is here. If we reflect it over line L, that means that that line becomes the perpendicular bisector. We go perpendicular to it and straight across it the same distance, and we would land on A. for part B, if we're going to take point A and reflect it over line M, that means that we are going to go perpendicular to line M and the same distance past it, so that these are the same, and that lands you on D. And you don't have to draw this line at all. I'm just showing you how that is calculated. Now, if you have a segment like BC here, and we're going to reflect the whole segment over line L, you want to do one letter at a time. Otherwise, you get them in the wrong order. So we're going to start with B, and we're going to take point B and reflect first over line L. Just point B, and we would land on A doing that. Then if we took C and also reflected C over line L, it would land on H. And so AH is our segment when BC is reflected over line L. If you had them the other way around, it would not be correct. So it is important to do one point at a time. Okay, next we're going to do the same thing with HG. So we're going to start with H, and we're going to reflect it over line M, which would land it to E. And then we're going to take G and reflect it over line M, which would land it on F. And so EF would be your answer. And again, it's important to do, making sure that you're doing only one at a time. All right, now for this, if you can remember that this little circle is a composition, it means after. We work right to left on these. So that means we're going to take point E, and first we're going to reflect it over M, and then we'll take that and reflect it over L. So we're going to start at point E, and first we're going to reflect it over M, which would land it on H, and then we're going to take point H and reflect that over line L, which would land it on C, and that would be your final answer. And just like the others, when you do a composition, if you're using a segment like FG, you're going to do first F and then G, and you want to make sure you do them separate. That way you get things in the right order. So first, the composition moves right to left. So first we're going to reflect over M, and then we're going to reflect over L. So if we start at F and reflect that over M, we'll land on G. And then taking G and reflecting that over L, we'll land it on D. And then we're going to do the same thing with point G. We're going to reflect it over M first, and then we'll take that and reflect it over L, and it would land on E. And this would be your final answer. So one point at a time, so they end up in the right order, because ED is not the same. Also notice, unlike translations, you cannot combine reflections for a composition. All right, next we're going to graph this parabola, so you can use a calculator to come up with a table, remembering that you're looking for this mirror effect here for your graph, and graph it. And then we're going to reflect it over the x-axis. So starting wherever you like, I've got the vertex here. We're going to count to the x-axis 1, 2, 3 units past, and repeat 1, 2, 3 4 units beyond, so that the x-axis is the perpendicular bisector. And that point would be for your image. Same thing for the next one. We're going to count. It's 3 units to get to the y-axis or x-axis, and then another 3 units to get past it. Same thing for this. Okay, and then the ones that are on the x-axis will stay there because you're reflecting over a line you're on. That doesn't change anything. And then for the ones above the x-axis, it's down 2, 3, 4, 5 to get to the x-axis. So down 2, 3, 4, 5 again. And the same for the final point here, down 2, 3, 4, 5, down 2, 3, 4, 5 to get that point there. And then we would have a second parabola. And this parabola has been reflected over the x-axis. Shortcut note, if you look at the coordinates for our y values here, this is now at -5, this is still at 0, this is now at +3, +4, +3, 0, and -5. So as a shortcut, a reflection over the x-axis will negate the y values. All right, next. If we look at number 5, If there's a point in quadrant 4, remember it's 1, 2, 3, and 4. For example, let's say 2, -1. And we reflected it over the y-axis, we would count to the y-axis and repeat back, and we would now be in quadrant 3. And another shortcut to notice is this would now be -2, -1, and it would negate the x. All right, if we go on to number 6, I'm going to plot -3, 6, and x equals 2, and we'll reflect over. So we'll count 1, 2, 3, 4, 5 units to get to the line. 1, 2, 3, 4, 5 units again. And we would now be at 7, 6. So reflecting -3, 6 over x equals 2 becomes 7, 6. And this is how we write basically the work for what we are doing. All right, I'm going to graph number 7. And to take 5, 1 and reflect it over the horizontal line y equals -1, it's 1, 2 units to get to the line and another 2 to get past it, making this point, which is at 5, -3. So 5, 1 reflected over y equals -1 is now 5, -3. Okay, I'm going to graph number 8, which will give me this horizontal line that has these points on it. If I'm reflecting each of those over the x-axis, I'm going to count to the x-axis and repeat that count back, and notice that now each one of these is going to be up at +3 instead of down at -3. So y equals -3 would become y equals +3, noting that the y value negated. I'm going to graph number 9. And I'm going to reflect this over y equals x, which is the positive y-intercept is 0, up 1, right 1. So to do that, I have to come at it perpendicularly. Remember that the slope here is 1 over 1. So perpendicular to it, we would go down 1, right 1, or up 1, left 1. So that'd be 1, 2, 3, and then I have to go a half. So there's the other half, 1, 2, 3, and this point would be my new coordinate. And so 3, -4 would now become -4, 3. And notice what happened here. There's a shortcut. Reflecting over y equals x switches your x and y values. All right, now I'm going to graph number 10. And we have the same concept. We're going to do perpendicular bisector. So for the slope here being -1 over 1, our perpendicular would be +1 over 1. So up 1, right 1, or down 1, left 1. And that's 1, 2, 3, 4 times. And doing it again, 1, 2, 3, 4 times would land me here at 0, -8, or -8, 0. And notice there's another pattern here. And so as a shortcut, if you're reflecting over y equals -x, you can switch x and y and negate both. Okay, for number 11. Write the line of the equation of the line of reflection that maps 1, 5 onto -5, -1. And if you notice, if I found the perpendicular bisector between those, between here and here, it would be this line, which is y equals -1 over 1x plus 0. And look what happened. They were switched and negated. So that is that shortcut that we discussed. All right, number 12. When -3, -1 is reflected over line L, its image is the point 1, 5. Find the equation for line L. So we have to do the perpendicular bisector. So the current slope would be up 6 and right 4, which is 3 over 2. Perpendicular to that would be -2 over 3. Bisector means we need the midpoint between them, which means we average our x's and average our y's, and that would be the point -1, 2. And so from there, we're going to count our slope down 2, right 3, down 2, right 3, up 2, left 3, and this would be our perpendicular bisector, which is our line of reflection. And so using point slope form, I can do y minus 2 equals -2 over 3 times x plus 1. And that is the line of reflection between those 2 points. We're going to do number 13 in class together, so I will see you in class.